Hello guys, my name is Charan HR. I am from Sri Venkateshwara College of Engineering. In this video, I will be discussing about probability distribution and its types. I hope it will be informative and helpful to all. Now I am working through Introduction to Probability Distribution. In statistics, the probability distribution gives the possibilities of each outcome of random experiments or events. It provides the probabilities of different possible occurrences. Also read events in probability here. To recall, the probability is a measure of uncertainty of various phenomena. Like if you throw one die, the possibility outcomes of it is defined by probability. The distribution could be defined with any random experiments which outcome is not defined or not predicted. Let us discuss now probability definition, types and its characteristics, along with how to create table of probability based on random variables. Now we can see. Before going through the probability distribution table, now we can see what is probability distribution. Probability distribution yields the possible outcomes for any random events. It is also defined based on underlying sample space as a set of possible outcomes for any random experiments. These settings could be a set of real numbers, a set of vectors, or a set of entities. It is a part of probability and statistics. Random experiments are defined as the result of experiments whose outcomes cannot be predicted. Suppose if we toss a coin, we can't predict what outcome it appears, either head or tail. The possibilities results of random experiments is also called as an outcome. The set of outcomes is called as sample point. With the help of experiments or events, we can also create a probability pattern table in terms of various and probabilities. Let us go through types of probability distribution. There are two types of probability distribution which are used for different purpose and various types of data generating process. Normal or cumulative probability distribution and binomial or discrete probability distribution. The first type is cumulative or normal probability distribution. The cumulative probability distribution is also known as continuous probability distribution. In this distribution, the set of possible outcomes can take as values in continuous range. For example, a set of real numbers is a continuous or normal distribution as it gives all possible outcomes of real numbers. Similarly, a set of complex numbers, a set of whole numbers, a set of prime numbers. As an example for normal probability distribution, also in a real-time scenario, the temperature of day is an example for continuous probability. Based on the outcomes, we can create a probability distribution table. A probability density function describes it. The formula for normal or cumulative probability distribution is P of x is equals to 1 by sigma root 2 pi e power minus 1 by 2 into z minus u divided by sigma whole square, where mu is equals to mean value, sigma is equals to standard deviation or standard distribution of probability, mean value is equals to 0 and standard deviation is equals to 1. Then this distribution is known as normal distribution, where x is equals to normal random variable. Some example for normal or cumulative probability distributions are height of population of the world, rolling a die once or multiple times to judge the intelligence quotient level of the children in competitive world, tossing a coin, income distribution in countries' economy among poor or rich, the size of female shoes, weight of newly born babies range, etc. The second type is binomial or discrete probability distribution. A distribution is known as discrete probability distribution where a set of outcomes are discrete in nature. For example, if a die is rolled, then all possible outcomes are discrete and give a mass of outcomes. It is also known as mass function probability. So the outcomes of binomial distribution consist of n repeated trials. The outcome may or may not be occurs. The formula for binomial probability distribution is P of x is equals to n factorial divided by r factorial into n minus r factorial into p power r into 1 minus p power n minus r. Or another formula is P of x is equals to c into n comma r into p power r into 1 minus p n minus r, where n is total number of events, r is total number of successful events, p is success of single trial probability, NCR is equals to n factorial divided by r factorial into n minus r factorial. 1 minus p is failure probability. Some example for binomial probability distributions in the real-time life. In that, to find the number of used or unused materials while manufacturing a product. To take a survey of positive and negative feedback from the people for anything. To check if a particular channel is watched for how many viewers. To calculate the survey of yes or no. The number of men or women working in company. To count of votes for candidates in election for many more. The last topic is Poisson probability distribution. Poisson probability distribution is a discrete probability distribution that represents the probability of given number of events happening in a fixed time or space. If these cases occurs is known as steady rate and individual of time since of last event. It is a title after French mathematician Siemens Dens Poissons. The Poisson distribution can also be practiced for number of events happening in the particular intervals, such as distance, areas or volumes. Some example for real-time applications are a number of patients arriving in clinic 10 to 11 pm. The number of apples sold in shopkeeper in time period of 12 to 4 am. The number of emails received in by the manager of officing hour or working hour. I think it is helpful for the engineers who are studying in 4th sem. Thank you for watching this video. Please like, share and subscribe.